Hey folks, so today we are going to discuss LeetCode problem number 309 and the problem name is best time to buy and sell stock with cooldown. So in this problem we are given an array prices where prices of I will denote the prices of a given stock on ith day, and now we have to find the maximum profit that we can achieve. But one condition that we were given in this problem is once we sell a stock we cannot immediately buy the stock the next day, so there has to be a cooling period. So it might be one or n number of days that we can take. So now based on these given conditions we have to find the maximum profit that we can achieve from this given array. So let's see what we can do. If you can see in this problem, there are a couple of observations that we can make. So on ith day we can, on any ith day for that matter, we can either buy a stock or sell it, right? So there are two options, but if you look closely into this, like there is another option, there is another observation that you cannot buy a stock once you have already bought it, right? So you have to only buy a stock only if you have sold it, or else, like if we have to put it in another way, like only you have to buy a stock only if you have not bought it in the most recent transaction. This is one observation, right? So another observation is we can only sell a stock only if we have bought it. Let me copy this guy here so that it makes clear. So we can only sell it if we have bought it in the most recent transaction. So this is the condition that we have on any given ith day. So what we can do is, what I'm trying to think of this solution is to perform a recursive solution on this problem, wherein on a given ith day, whether I'll check whether if we have already bought some stock in the as the most recent transaction or not. If yes, I'll perform some set of some kind of transactions, and if not, I'll perform something else. So let me write it down. So let me write a recursion function in which I'll be taking my I, and I also want, like if we can see this dependency, we have to tackle it using another variable apart from I. So for this reason, what I'm taking is I'm taking another variable which is called isBot, which will be having either 0 or 1 as the values. 0 indicating it was not bought previously, that is like we can now buy. So this would be the condition if our isBot is 0, right? So let me write it down. IsBot is equals to 0. So if our isBot is equals to 1, so then we can sell it. So this would be the condition. So on this basis, what I want to do is, like I'll check if my I is greater than, like simply I'll be traversing from the left to right, okay, from the 0th position to the final position. So that's why what I would be doing is I'll be finding whether my current I value is greater than or equals to length of prices, that is, like it has reached the end of the array. In that case, what I'll do is I'll return simply 0. Otherwise, what I'll do is we have to check at every step, like whether we have previously bought any stock as our most recent transaction, right? So what I'll do is I'll do this. If previously, that is most recently bought, in this case, else case. So this will give us like, it might be either if previously, if it is not recently bought, that then it must be either sold or none of these transactions have taken place. That is like, at the 0th location we have not either bought anything or sold anything, right? So in that case, like, we will be getting into this else condition. So what if if we have bought it recently, then the only option we have is either to sell the stock on ith day, or else to move forward. Like, we can completely ignore the current step and we can move forward, right? In which case, what I would do is maximum of prices of I, because we have to consider this like a particular day, because we have recently bought it. So the only thing that we can do is we can sell it and on the given ith day. So once we sell it on given ith day, we cannot go with I plus 1th day, because like, as we can see, there has to be some kind of cool down period that needs to be done, like as you can see here, right? So there has to be cooldown. That means what we can do is, if we sell the stock on ith day, then we can perform this recursion from I plus 2th day, because we have to completely ignore I plus 1th day. Or else what we can do is we can ignore the current day, right? So in that case, our function would become recursion of I plus 1 comma 1, because as we have already told, like, my isbot will be having either 0 or 1 values, right? These are the values that my isbot will be taking. If it is 0, that means like, we have not recently bought it. That means we have sold it in the very recent, as our recent transaction. So now we have to buy it. If my isbot is equals to 1, that means we have recently bought it, now we have to sell it. So this would be my maximum of sell now or ignore now condition. That means we will either sell on the given ith day, and we will recurse from I plus 2, because we have to take a consideration of cooldown and consider cooldown on I plus 1th day, or else we can ignore the current day. So that is what we are doing. So because if my isbot is equals to 1, we have to like, forward, like, recursion, we have to do the recursion with I plus 1 and sending isbot is equals to 1, right? So this is the maximum value that we'll be getting. And if it is the else case, then what we have to do is we have to take the prices of I, that is we have bought it now, plus we have to do the recursion on I plus 1, because if we have bought it today, we can sell it tomorrow. That is the condition that we can do. So, and we have to update the isbot value, because here, since my isbot value would be 0, because if it is not isbot, that means isbot is equals to 0, right? So then in that case, we have to change our isbot value to be 1, right? And similarly, we have to we can do either this is the case of buy now, max of buy now, and we don't need to consider any cooldown on the I plus 1th day, so we can completely do the recursion call on I plus 1th by updating the isbot from 0. Here it would be 0, right? Isbot is equals to 0, and here it would be 1. So then in that case, we have to consider the prices of I plus recursion of I plus 1 comma 1 and recursion of I plus 1 comma 0. Sorry, here, right? We can either buy now, or else we cannot buy now, and like, we can recurse on the I plus 1 without buying it now. So ignore current day. So this is the option we have in the else case, right? And okay, sorry, I also forgot it here to uh, update our values. Like in this case, if we sell on the current day, then we have to update our easebot to 0, right? Because we have sold it. So now we are updating the easebot value to 0. Then we can recurse it in the future days and see that, like, we have not recently bought it, but we have sold it. So that would be the condition we are taking it here as part of prices of I plus recursion of I plus 2 comma 0. And if we are doing recursion of I plus 1 comma 1, that means we are ignoring on the current day and we are stating the future transactions that we have recent performed, buying as an option as our most recent transaction. So similarly in this case, but if you can see this, like, we cannot keep adding these values. Like if we take this example, so in this example, the maximum profit that we can attain is by buying and then selling on the first day, buying on the 0th day and the selling on the first day, and then having a cooldown, and then buying it again and selling it again. So these are the sequence of transactions that we have to do on this particular input. In that case, what we'll be getting is 2 minus 1, because we have bought and sold, right? So whenever we are buying, like, it makes sense to add multiply it with -1, because it is given as 1 and the price is 2 on the selling date. So we are adding the same value in the selling date, but we are multiplying it with -1 so that we can get the final answer as correct, right? So in the similar way, we are doing 2 minus 0 for these set of indices, the last two indices. Like, we are buying on the third index, and we are selling it on the fourth day. So in that case, we are getting this. So similarly, whenever we are buying a stock, that is when we have to multiply it with -1 so that we get the final result to be right. So this is what I'm doing it here, and I'm multiplying the prices of I with -1 whenever I'm buying, because my easebot is 0, that means I can buy now. So I'm multiplying it with -1, and then I'm performing recursion on the I plus 1 day. So once this is done, I have to return max of these two values. If it is like, if A1 is my answer here, if A2 is my answer from this, so I have to return A1, like, whichever value is possible. But if you can see, like, there is a overlapping sub problem that we can see, that like for every buy and sell combination in the first, from starting, so we are traversing through the entire list from 0th index to last index, and then we are coming back again, and this keeps happening, right? So in that case, what I am trying to do is I'll be taking a DP array, which will be, I'll be initializing with -1s initially, and for I in range 2. For this, like, I'm taking in this format because what I want in the DP array is something like this, like, so this one will be my easebot is equals to true, this array, and the and this would be for the this one would be for false, because my easebot would be 0, right? So for that purpose, like, it can take two values, because if we can see, like, we are having two variables in the recursion function, so we'll be having our answer based on changing of these two values, both I and easebot. So our answer will be dependent on these two values. So I have to consider both values when I'm taking the DP array. So that's why what I'm trying to do is the I would be length of prices, like the maximum value that I can take is length of prices minus 1. So the total number of different values that I can take is length of prices. So for each possible value of easebot, I am taking one array for it. So it would be like a matrix. Totally my DP array would be a 2D matrix with a number of rows is equals to 2, but the number of columns would be equals to length of prices. So before this step, to just avoid the overlapping sub problem case, like to avoid more and more computation of the same sub problem, what I'll be trying to do is, if dp of is bot and I so is not equals to -1. So if you have already computed the value, then what I would do is return dp of is bot and I, right? So otherwise we'll perform all these things, and even in this case, like I'll store these values in dp of isbot, and then I'll simply return the dp of isbot and I. So this is the recursion function that I want to do, and once I come out of this function, like I have to call this function, right? So for that purpose, what I'm trying to do is I'll be calling my recursion starting from 0th index and telling that I have not bought anything, because we cannot buy before the 0th index, right? So that makes sense, and dp of 0 would be storing this value now. And also, like we were given that we can see that, especially that, like if we don't have any value, that is, like if our value is -1, let's say, even after performing this recursion function, if our dp of 0, 0 value still says to be -1, then we can say that, like there is no profit that we can gain. But we should not return dp of 0, that is -1, right? So we cannot return -1, so simply we'll return 0. For that reason, we'll return 0. So we'll return dp of 0, 0 if our dp of 0 is greater than 0, else we'll return 0. That is, like if our dp value is less than 0, in that case we'll return the answer to be 0, otherwise we'll return the dp value to be greater than 0. So let me check if this is working fine. Yep. So let me submit it. Yeah, so this looks good now to me. So yeah, that's it for the day, guys. So if you really like my video, then please like and comment to this video. That keeps me motivated to upload new videos and solve new problems. Thank you.